Derivative of trigonometric function. If f of x is sin x, then f is differentiable at x belongs to R at a point x, then f dash x is cos x we have to find. What is asking is simply we have to find derivative of sin x. We know that sin x derivative is cos x because all trigonometric solutions sin x is cos x is minus sin x, tan x is secant square x, so on. So now let us see how this cos x is derived. Now we know that by differentiation definition, if f is differentiable at a point x, say for example here a, in our case x belongs to R, a belongs to R. So at a point x belongs to R, we have to find out. So the definition is given is if f is differentiable at a, then f dash a means here in our case f dash x limit will be equal to limit h tends to 0 f of a plus h minus f of a by h. Here in our case, because we are doing at f of at x at a point x, the function is sin x. So the function is sin x. The function is sin x and point is at x. Okay, we have to find out the f dash x. We have to find out, right? F dash x we have to find out, right? So for that, see, f dash a will be equal to limit h tends to 0 f of a plus h minus f of a by h. In our case, in the place of a, just you put x. So therefore limit h tends to 0 f of x plus h minus f of x by h. But here f of x is just here, just a function f of x is given. Here in our case f of x is sin x. The function is sin x. Here the general function f is given here. So general function f of x is given. So then f of at a point a we are finding derivative, that is f dash a is equal to limit h tends to 0 f of a plus h minus f of a by h. In our case f of x is sin x. Sin x function we have to find out. Here the function is just f, the sin x. So wherever the place x is there, that is wherever that is a we are calling here a plus h, we are just small increment we are doing. What is actually differentiation? Differentiation is nothing but it's a if at a point a from left limit and right limit both must continuous at a point a. So it is arriving from left to a or right to a, so there should be a continuous, there is no discontinuous. So continuous, then we are finding the rate of change of x. Differentiation is nothing but rate of change of x in how fast it is approaching a from both sides without any discontinuity is called the differentiation. That's what we call is a continuous function. So all continuous functions are derivable, but all derivable functions are not continuous. Very important. So a function to be derivable, it must be a continuous. What is continuous? Left hand limit equal to right hand limit. Left hand limit equal to right hand limit, and both equal to f of a. At a point a, limit x tends to a minus limit x is equal to left limit x tends to a plus, that is equal to limit x is at a, f of a, right? So that's what you have to find out. So therefore this f of x is, so sin x, in the place of x we have to just put x plus h, small increment, f of x plus h, f of minus f of x, here a plus h minus f of a, here by h. Okay, so this is we have to find out when h goes to 0. Therefore sin of h plus x, sorry, x plus h minus sin x by h, this is finally we have to evaluate. That's what the answer we are going to get. Okay, this is the finally we have to evaluate this limit h tends to 0 sin of x plus h minus sin x by h. When h tends to 0, whatever the value, that will be the derivative, So this we can do sin c minus sin d. We can call the sin c minus, what is sin c minus sin d? From trigonometry, sin c minus sin d is nothing but sin c minus sin d is 2 cos c plus d by 2 into sin c minus d by 2. So therefore x plus h plus x by 2, that is 2x plus h by 2 will be cos of c plus d into sin of x plus h minus x get cancels, sin h by 2. So therefore this, after applying sin c minus sin d, you will get 2 cos 2x plus h by 2 sin h by 2 by h. This again after simplification. So what we are going to get is, this is 2 limit 2 I have brought this side, cos 2x by 2 plus h and separated into limit sin h by 2 by h. This h brought downside bought this side, here I bought. Okay, here no, not necessary. Here only cos 2x plus h by 2, and here 2 sin h by 2 by h. Now separated limits, 2 also brought outside because it's a constant. Limit h tends to 0, what this value, simply it is when you put h is equal to 0, that is 2x by 2, it is just x, cos x will remain here. But anyway separated, 2x, 2 cancels, 2x by 2 cancels, 2 cancels, and h by 2 remain. This is what. As h tends to 0, h by 2 also goes to 0. As we can see that h is going to 0, automatically h by 2 also goes to 0. So therefore this will go to 0, this will go to 0, and you will remain only cos x. This limit coming to this sin h by 2, here h only is there. I just multiplied with 2 and divided with 2. Multiply with 2, divided with 2. And 2 you bring out from out of the limit. So it will become 1 by 2. So limit h, as I told you, h tends to h by 2 goes to 0. H by 2 goes 0. Sin h by 2 will remain here by, again downside also h by 2. So sin x by h. Limit, we know that limit x tends to 0. Limit x tends to 0. Sin x by x is what? 1 only. So this whole becomes 1. So it is 1, it is 1 by 2, and here as h by 2 goes here cos x. Therefore 2 already is there. 2 into cos x into 1 by 2 into 1. So 2 get cancels and only cos x remain. Therefore f dash x is cos x. Then finally the derivative of f of x sin x is f dash x cos x. Hope you understood. We'll stop here.